Okay. Hi, everyone. Thank you for joining and welcome to the Dapr community call for July 26, 2022. This is community call number 65. My name is Nick Greenfield and I'm a Dapr maintainer and I'll be the host for today's call. We have a fun agenda, so we're going to get right into it. So starting off, we have a special announcement, an update on DaprCon. Yes, DaprCon is back. So Nimade and Mark will talk a little bit about that and what you can expect from DaprCon in 2022. And then we're going to move into, we're going to continue a conversation that we had in the last community call around pluggable components. This time, we're going to take a look and do a deep dive into the proposal itself, where John will walk through that. Next, we're going to take a sneak peek at a feature that's being released in the 1.9, or it's targeting the 1.9 milestone, which is the health check endpoint API for components. And then lastly, Archer will show a feature that's available today, which is pub sub subscriptions with stateful sets. And then as always, we wrap things up with an open discussion. Anything that's top of mind, we can use that time to discuss as a group. And so without further ado, we'll move into the first topic and encourage conversations. Please feel free to use the chat, or we'll try to leave time in between topics if there's any questions on the topic that we just covered. All righty, let's get into it. So first up, DaprCon.
I can go ahead and start this slide. And then Mark, feel free to jump in if you want to add into this. But yeah, so we are doing DaprCon again. It's coming back this year for 2022, but it's going to look a little differently. So this year, since we are now officially part of the CNCF, we're actually going to be doing DaprCon hosted by them. So DaprCon is going to be a part of KubeCon North America 2022, which is happening in October. And essentially, DaprCon will be one of the experiences or events you can go to during KubeCon. So KubeCon will be from October 24th through October 28th in Michigan. But DaprCon itself will be held on October 25th on the Tuesday of KubeCon. So we'll be a part of that huge con that's going on. We'll get a lot of really great just foot traffic and getting more attention on Dapr. So that's super exciting. But takeaways you should probably know about this: we're in very early stages still discussing what this is going to look like with CNCF. The only thing we're pretty much solid on is the fact that we're going to do a DaprCon. So what we need is some help from the community. So we created a form that you can use to kind of just submit your content. So this is for you to kind of, if you would like to do a presentation during DaprCon, you can use this form to basically submit what you're thinking of presenting on at DaprCon, what you would like to talk about. So this would be any type of, cool ways that you've used Dapr, different types of, technical challenges you handled with Dapr, et cetera, et cetera. So this form will be posted in probably the community repo. Me and Mark haven't discussed where we're going to actually have the form live itself, but we'll be accepting submissions from today, July 26th through Friday, August 19th. So get your submissions in by then if you would like to present at DaprCon, and we'll reach out to you via email if we decide that we do like your submission, we would love you to join DaprCon. But yeah, outside of that, Mark, did I miss anything there?
Nope, you covered everything. So it can be a fabulously exciting event. And we really look forward to your submissions. You can do all sorts of types of talks, a deep dive into some technical area. You can do a lightning talk covering how you use Dapr inside one of your solutions and build it into your end user products, or join on a forum, on a panel. A panel, yes. And there are many different ways. So any way that you'd like to kind of join in and have content will be truly appreciated.
So Mark and Nimade, I know you mentioned discussing where to put this form, but is it safe to say that the community should keep an eye on the community repo for updates?
Yes, we'll do two things. We'll publish it on the Discord channel, just to put a link there, and we will also put it in a issue in the repo. And the form is really a call for papers. So it's kind of, you fill out the form and you say, put a title of what you're talked about, what the type of talk is, who you are, and then a description of what the talk is, so we can sort of review this and build a an agenda for the day.
Awesome. Looking forward to it.
Cool. So we'll go ahead and post that link, and probably we can just put in the announcements channel to announce DaprCon and give everyone the form, and then also just have it in the community repo, or the 2 locations you can find it.
Great. Alrighty, thank you. All right, moving on. John, feel free to continue the conversation from last week on the pluggable components and looking at that proposal.
Yeah, sure. Sounds good. So I'm going to find my browser real quick. Open the proposal on GitHub just so that we can follow along. Sorry. All right. Share my screen. All right, can everybody see my browser?
Yep, looks great.
All right, cool. So last time we briefly went through a demo of the sort of existing set of features which are covered by this proposal. This GitHub issue proposal is it's a continuation of the previous one. It does not deviate dramatically from the long-standing proposal for implementing pluggable components. And I think just to get everybody on the same page, the goal of pluggable components is to allow people to build and ship components that are not necessarily compiled into the Dapr binary. The immediate need is largely for users and customers who are using Dapr but have internal, I guess that's a polite code word for private components that they're working on, and to allow them. Right now they have to maintain forks, for example, so they have to constantly keep up to date with upstream Dapr, any changes that they've made, right? They have to deal with inlining all those and taking those diffs. So the first goal of the pluggable components is to allow people to build those components in such a way that they don't have to continue maintaining basically their own copy of Dapr. As part of that, obviously, one of the primary goals of that is to do it in such a way that is flexible for users, is easy to understand and develop, and also minimizes any sort of performance penalty. I mean, obviously, anything that doesn't run inside of the Dapr binary is going to, by its very nature, incur some form of penalty, right? Because you're leaving one process and going to another. So, this model enables people to build these components in such a way that they can run them outside of the Dapr binary. And as we showed the last time, they are communicated with over gRPC. So in effect, the Dapr daemon will implement and currently implements a set of stubs, which are gRPC implementations of the component types. So for example, state store has a protobuf definition for get and for set and for all of the things that go with the state store, like bulk set. That stub gets created every time you construct a new component, just like the Redis component, for example, creates a new Redis client for every component you create, and connects to an external gRPC service. So one of the caveats of this is that, we're deliberately not looking at, for example, running these on separate machines. So running over TCP or other things, among other reasons, because that now brings along security requirements and other things that folks have to deal with. So the primary expectation for this release, at least, is that the processes are on the same machine and able to communicate over Unix domain sockets for performance reasons and security reasons. Also, because we're using gRPC as part of this, in large part because we already depend on and use gRPC all throughout Dapr, so it's a well-known model. We're obviously not going to be targeting, at least supporting, languages that have, don't have some sort of compiler for protobuf or gRPC. So I think one of the other things that this touches on in the long term is that, Dapr as a binary, as the number of components that are available grow, so does the surface area and the number of dependencies, and the chance for not only security issues, but also code conflicts, far-reaching changes. For example, recently there was a change to one of the components that facilitated or necessitated upgrading from upgrading Go so that we had support for generics, right? And so while not necessarily the specific goal of this proposal, I think that having pluggable components allows us to, as a community, increase the overall long-term health of Dapr, because it means that, for example, we can introduce new components that are inside of Contrib as external components, if we decide to follow that model where, before we put them into the Dapr binary, maybe they have to reach a certain phase or a certain life cycle. So, these are things that this will enable down the line that we can start to think about as a community, right? And again, like I said, the primary issue right now is really a lot around adoption, which means that, companies and individuals who are using Dapr who want to build extensions to Dapr can now, with this feature, do so without having to rebuild and maintain a Dapr fork. Another side benefit of that is that people who are building components and integrating Dapr with existing systems, not everybody has Go experience, right? And so while they may be comfortable with operating, configuring, and running Dapr, they may not have the resources available to dedicate to building a new component in Go. And so for those types of users, let's say they live in the Java ecosystem, rather than having to rebuild all of their existing logic for the things that they want to integrate with, they could simply build a gRPC service in Java that implements whatever component interfaces that they're going to be building, and they can reuse their existing Java code to communicate with whatever upstream services or upstream components that they have. This will dramatically reduce their development cycles in terms of both implementing and maintaining these features as well. And another one is also there's a set of components that may be open source, but that require either some library that only exists in a certain language, or for example, require C bindings. Like we've traditionally avoided, for good reason, I'm sure, using anything that requires CGO because of the challenges that you face in terms of portability and other things. And so this model also offers us the ability to write a feature in Go, but that requires and depends on a C library, so that we don't have to change the way that we build Dapr or other things in order to implement that particular feature. So as I mentioned before, the proposed mechanism for this is effectively, there's a fixed set of lightweight stubs inside of Dapr that have protobuf definitions that match the component definition. So again, state store has set, get, bulk set, init, all of the things that you would traditionally see if you were implementing a storage component in Go. You have the exact same one-to-one mapping in the gRPC component. And then the other half is, the actual service that does the implementation. So, let's say you wanted to re-implement Redis in .NET, right? That's pretty easy to do. Maybe if you wanted to have your own custom logic inside of it, you could add your own custom company-specific logic inside of that. And then that component simply needs to listen over a domain socket for, a gRPC connection from the Dapr daemon. And, as we talked about in this proposal, right, like the ability to have this running outside also means that, if the component encounters a bug, it means that Dapr can potentially gracefully degrade, right? You only lose, whatever portion of the system was affected by that particular component running outside of Dapr. So this is, this is kind of a brief overview of how this model works. So again, inside of the Dapr daemon, we have these stubs for the variety of components, pub sub, state store, config store, et cetera. and then they communicate with these component implementations over the Unix domain socket. To be clear, this proposal does not suggest or recommend or have any notion that we should take existing components and remove them. That is, a potential future area that we as a community can consider. Really, this is about building new components for implementations where, again, like building it into Dapr or building it in Go, do not necessarily make sense for whatever reason that happens to be. As part of this proposal, I'm proposing also that, when you package a component, that people use Docker images as the default mechanism. To be clear, this is not necessarily the required mechanism. The only hard requirement is that at the moment that the gRPC client inside of Dapr can communicate over a Unix domain socket with the gRPC service. The reason that part of this proposal recommends that we use containers for folks as like the default packaging is a variety of reasons. One is obviously that it means that as a consumer of a pluggable component that someone has written, I don't need to manage any of the dependencies. I don't need to manage having the right version of the JVM or the right version of Python or Ruby or whatever happens to be written in. It also means that the life cycle of that particular component is, fairly straightforward. You download the container, it runs, and you're off to the races. As long as you can have a shared volume or something between the that container and the host, so that you can do the actual gRPC communication. But again, it only really requires that you have access to a domain socket, so that if someone so chose, they could run their own, they could run those components by hand, running them as like system services. They could start them manually, whatever it is that happened to work inside of an existing orchestration system, whether they're using Chef, Puppet, Ansible, like whatever it is that they're using, if they're deploying standalone mode. Also, the container model is convenient, and because a lot of our customers use Kubernetes, translates well to the Kubernetes deployment model. So I think that containers as sort of the expected default bring a lot of benefits, but I also think it's important that it not be the only way that folks are able to run external components. So just for completeness as part of this, there were a variety of other options that were also thought about or considered, because it's important to make sure that even if we choose the technology that makes the most sense in terms of existing support and what have you, that it's the right one, right? And gRPC and protobuf has the benefit, several benefits. One is that it's a well-known model inside of Dapr. We already have plenty of protobuf definitions. That's what we use for all of the SDKs. All those kinds of things. So we don't need to change the way that we think about, how we as a community interface with Dapr or Dapr components. Obviously, the convenience of automatically generating stubs for both clients and servers, and the latency is quite low. Obviously, there is some amount of latency, and so as follow-on work, as part of this, one of the things that we're looking at doing is ensuring that we have benchmarking numbers for pluggable components, so that people know, okay, for example, like if I'm a customer of, I'm using Dapr as a user, if I have this particular use case, I may need to build a component into Dapr because, maybe the performance overhead or what have you of making those gRPC calls is too much for an extremely high load system or something else. So, making sure that we identify those particular corner cases is important, I think, also for adoption. Obviously, some of the downsides to any of these are, slightly higher latency. gRPC and protobuf only talk over HTTP2. It doesn't use the Go standard HTTP library. None of these are necessarily blockers, but they are, additional overhead or things to think about. Some alternatives that include using protobuf, right? There's 0MQ, which is a very similar, sort of RPC model. Again, it reuses protobuf, but the downsides are that it requires a whole new way of doing things. It's not the way that we currently do stuff inside of Dapr. There's a variety of different libraries. Some of them require C, which puts us right back into the like C Go FFI universe, which we like to avoid. And there's no sort of auto implemented components. So, you know, the gRPC model is really nice from a developer perspective because it means that you don't have to worry about, you know, building these boilerplate things from scratch. Twerp, again, you know, it's fairly similar, but I think the real downside is, again, I think there's a lot of value to keeping things sort of the principle of least surprise, right? So that things work the way everybody expects. So you don't have to learn, you know, dramatically new ways of doing things. For completeness, I included writing your own custom written IPC library. This obviously could have the benefit of raw performance, but for anybody who's ever implemented a custom IPC library or done any such thing, there are all sorts of problems that you can run into, right? Bringing down the Dapr daemon primarily being one of them very easily. I know we've also talked about using like Go's plugin system, which is another option. Downsides being that, you know, it still requires things written in Go. As of the last time I checked, unless something has changed recently, it only supports Unix-alike systems. There's no Windows support. You know, and it historically has been sort of fickle in regards to the like being built against the source tree that the plugin is going along with. So I think that, you know, there are also conversations that have not been included. You know, there's also the open question of like, why not WebAssembly? I think that is an interesting possibility. And I don't think that the concept of pluggable components excludes the future idea of building them in WebAssembly if we find that as a community that WebAssembly is mature enough and provides the right level of you know, interface and performance. But I think that for the needs that people have currently with regards to building you know, external components, that I don't think that WebAssembly does not solve that set of problems right at this time. And so, you know, again, I think that that's definitely an area that we can explore together in the future. But I think that for right now, the gRPC model provides the best in terms of low overhead and in terms of both performance and mental model, and also the largest flexibility in terms of, you know, implementation of the pluggable components themselves by users. So again, in this proposal there, you know, I did some preliminary, you know, latency measurements using some benchmarking and stress testing tools. It's actually quite low in terms of overhead, but again, we definitely want to fully quantify what those look like so that people know, well, A, that, you know, as we make changes to Dapr, we don't regress in terms of the performance of the system, and also B, that this system meets their needs depending on their use. You know, I think other areas for sort of future conversations are, you know, like, are there other ways that we should package things, right? Maybe, you know, CNAB or something else. Should we consider how to safely support, you know, cross-host or, you know, TCP or other sorts of network protocols for doing these types of communications? What about dynamic registration of components? So instead of, you know, defining them, maybe they're able to self-register or other things. So, you know, I think that this is an exciting area for us as a community to have future growth, both in terms of, you know, project health and functionality and other things. But also, I think, you know, it's a great way for folks to start contributing to Dapr if they're not necessarily Go programmers. I think there's a lot of value in having a community where, you know, people with all skills can provide something of value. So that being said, you know, I think that this proposal has a lot of interesting things that I enjoy seeing in Dapr. I think that reducing the footprint and a variety of other things in the future are also, you know, really interesting places that we can take Dapr. So with that being said, you know, I'm happy to, if anybody has any questions or things that they want to bring up or talk about, then I'm happy for that.
Yeah. Hey, John, this is Yaron. Really great write-up. You know, we've been talking about this for a while. I think it's a great proposal. Just a few things. Can you scroll up to non-goals for a sec? Yeah, so because we're using Unix domain sockets, do you think we might want to add Windows support for non-goals since it's not going to be usable on Windows?
So my understanding is that Windows, after certain versions, has Unix domain socket support. But there are some restrictions. So are you saying not all versions of Windows? Is that what I heard?
Yeah, I mean, if we're taking it like that, if we can't, provide a measure by which we can guarantee that it can just, run on Windows the same way it does on Linux, maybe we should put it as a non-goal, meaning, it might work, it might not, it's not supported. And so we should treat it as a non-goal because we're not going to be testing it on Windows.
Okay, yeah, because I do know that like as of 2017, there's support for Unix domain sockets inside of Windows. But again, I don't know the exact details and like, so yes, I think it's probably good to put in maybe that we're not having full support out of the box, at least, immediately for Windows. I would love for us to, but I think that's probably a good idea.
All right, yeah, thanks. And regarding WASM, we have WASM support for middleware now in Dapr, and we're running into a few issues there. I do agree with Arthur that WASM in the long run is going to be a pretty good way to extend Dapr. But there's a few things that need to be solved in WASM upstream, specifically in WASI, the server-side implementation of it, regarding threading and networking APIs. They're not fully matured yet. But once and if that comes to pass, I think WASM will be another great extensibility point for Dapr components.
No, I do agree. I think that WASM as a technology has the potential to provide that common runtime so that you could write those plugins in Rust or whatever can compile down to WASM.
Yep.
And to your point, my only concern right now is that a lot of the runtime implementations are like pick a method name that's defined by some arbitrary string and invoke it and cross your fingers.
Yeah, exactly. Yeah, no, I completely agree.
So.
And just one last thing, based on our conversation, it's my understanding that this proposal does not include, Dapr spinning up containers anymore, right?
Yeah.
All right, cool.
All right, cool. Sounds good. Thanks.
Yeah, thanks, John. So this is this proposal for everyone is in the Dapr. It was 4925, the issue number, I believe, John.
Yes, 4925.
Great. So please take a look, provide feedback, and we'll have the discussion on the proposal. So thanks, John. Good to see how we can extend Dapr with pluggable components. Okay, next topic is Deepanshu talking about the health check API for components. Deepanshu, feel free to take the stage.
Sure. Thank you, Nick. Let me share my screen. This should be a quick one. I hope my screen is visible now.
Yes.
Okay. Okay. So, so this is regarding the health check endpoint for components, and we are intending to have two type of endpoints here. One, inquiring the health of all the components, and second, having the component name in the URL and inquiring about it. It will be in both HTTP and gRPC APIs. Okay, so moving forward, the sequence diagram looks very simple for this one. It is like we may have any HTTP or gRPC call, and the middle layer is the component layer inside components contrib, just like we have Redis Go or respect.go, etc. So first of all, we just inquire about whether the ping, we are introducing a pinger interface with the ping method over there. Just inquiring whether the ping is implemented by that particular component layer or not. If it is, then it is simply inquiring the health check via that ping implementation. So if it's okay, then reporting, and elsewise. Okay, so in components contrib, so this part is important, whether the ping is implemented or not, because till now, in a state store interface, for example, this was a mandatory function. So what was happening that in many of the implementations in a status store, it was implemented wherein we were just simply returning nil without checking the ping. So it could give a false positive sense, like a sense of false sense of health correctness, which is wrong. So we have made it optional, and thus only those components which are implementing ping correctly, they would be implementing it. Otherwise, like, we will be returning that the ping is not implemented. This was one of the change in components contract. In the Dapr repo, it was simply like introducing 2 endpoints, which we talked about. And in case of all the components, we return an array with like each result element telling the health of a particular component, which type it is, the status is okay or not okay, and undefined, which would mean that the ping is not implemented. So we cannot basically inquire whether the health is fine or not. In case of the second one, the B one, so we simply inquire for a particular component and we return a corresponding HTTP code with error code in the message if required. We will we can quickly see a quick demo. So I intend to load 4 components over here. One is like the PubSub SNS SQS from AWS, which is not implementing ping implementation, whereas all other 3 components, the product PubSub and SMS binding and the transaction store, they are from state bindings and PubSub, and all are from Redis. Now these components are implementing ping interface. So let me just quickly start my Dapr. 1 second. Okay, the app is started. We can quickly check about these 4 components. Okay, so this is an HTTP. So this was from AWS, wherein the ping is not implemented. So a status is undefined and error ping not implemented by PubSub. Whereas in others, it is like it reports okay. Very quickly, let me just to show it very quickly. Let me just stop Redis one, and let me just quickly inquire again. So yep, it will report that it is not okay, health not okay. Similarly, we have this one in gRPC, wherein we would be able to see for all the components. Yep, unimplemented end. I think that is majorly from my side. Yep.
Cool. Yeah, this is a good way to quickly check the health of a component. Thanks for showing this demo. And this is, just to be clear, this is as of now a preview of what's to come in potentially 1.9 of Dapr.
Yeah, correct. So the changes for components contrib, they were merged and in 1.8 itself, but yeah, they are like incomplete without Dapr repository changes, which are supposed to go in 1.9. Yep.
Can I ask a question?
Yeah, sure.
So I wasn't quite clear with ping of what it returns. So does ping like a health API on a component? And why is it called ping? Is it returning just a state? What does it return? Type of status code returned? Is it like health status codes, or is it just I'm there?
Yeah, it is like health check API. So let me just so in case of like we inquired about all the components, it returned a result array with all the components, associated components, and their health. So wherein the status and error code optionally will return the health status. And if you want to inquire about, let's say, for a particular component, order PubSub, so herein we can simply inquire about it, and it will return 501 not implemented accordingly. Or let's say we inquire about transaction store, which is like the Redis one, which is implemented, and I hope I had started it. So it will return 204. That's this one with no content.
I guess I was asking why you called it ping as opposed to just health on a component, because it's about the health of the component, yes? So the reason why you call it ping as opposed to component health, because so there's a health of the components on the sidecar, giving an array return of all the components, and then there's a health on the individual component, which is just your health of the component status. So it kind of makes sense that they sort of matched, yes, because you're asking for the health of the component, because it could be several statuses, yes? I guess there are a few statuses. Is that not the case?
So you're saying that why it is called as ping instead of like some health, correct?
Just call it health because it's the health of the component. Yes.
I think there were some discussions that had gone earlier, before even I had started. So this pinger interface, like in the package health, was like there was some discussion that had gone, and then we had finalized with this pinger interface. If the general consensus is that we should change it to something giving a direction towards that it is health instead of ping. So yeah, I would be fine to change it.
You should
But
describe
yeah.
what it does rather than what it pretends to do. Yeah, I think for me, calling it health because it's about the health of the component is clearer than calling it pinger, which could mean other things or unclear, but that's the way I look at it.
What I had perceived it the way I see it, like it's like checking the health, checking the heartbeat of the component. So, but if you feel that ping is not implying that one, then we should change it to health. Yeah.
I think the API does use health, right?
Not
The API itself.
on the side.
Yeah, the API itself the API itself uses health.
Yeah.
Yes, the
Yeah.
API itself uses health.
Yeah.
Correct.
So I personally I don't mind the ping name, but I would say we can do like a quick survey on the issue and ask about preferences about naming, but I'm fine with ping.
Yeah, I think we also want to think about user experience, right? So like what's the way in which users find out things about their components? Today it's metrics. We have many metrics for components. Usually, you're going to have something like Prometheus, which gets your metrics, and then you're going to have something like Grafana or another, dashboard on top of that, so that users can see the actual error rates or requests per second that go into a component. So, for example, what I think would be really beneficial is instead of letting developers write, boilerplate code that talks to these APIs and gathers the info, it'd be really great, for example, if DaprD could, once any given interval, ping the actual components and then push that into the metric store using our existing Prometheus endpoints. And so this would really play well with existing ways that developers track Dapr health in general today. Instead of like having an API endpoint to track component health and then having, metrics for health of other things in Dapr, it'd be great if we could combine this into the metrics. Now, I'm not saying to remove the API, it might be beneficial for other means. If you're writing some sort of platform that does like health API-based aggregation, that's fine. But I think getting it into metrics is going to be really beneficial to a large set of Dapr users.
I think the health API has advantages if you're using that on Kubernetes. We can maybe that's a change that should be included here, a way to make this part of the Dapr sidecar readiness check.
Mm-hmm. Yeah, no, definitely. I'm not saying replace the endpoint. I'm saying augment the current implementation with metrics.
Yes, I agree. And the thing is like we need first of all see how this works in Kubernetes. So I'd like to follow up on that after this call.
Yeah.
With Dipanshu. Yes, metrics is definitely something we can add on later too, because if you could have the metrics and don't have necessarily the health check API to be pinged every minute or so. But yes, I agree with that, Stephen. We should look at metrics as well.
Yeah, and also realizing that it might not just be the health API that calls each component. It might be other things that call components as well. So just saying to go through the health API and hiding the ping isn't necessarily true. So I just think you should make sure that you have names of things that correspond to what they do.
Yeah, just because calling I think the method is doing an action, so that's why ping was chosen. So if you want to do health check, we have to make sure like we name it properly, like health, like check health or something like that.
Yeah, that's fine. Yeah, because yes.
Yeah. Also, one last thing. Can you show the response body again, please?
Yeah, sure. For the components.
Yeah, for components.
Sure.
Yeah, I mean, it looks okay. Like the status is string is okay and not okay. Can you go to a not okay example? It's just
there's a not okay example right here too. I made a comment asking to remove the type from the error message, from the status. Sorry, from the error.
Yeah,
Okay.
so I think that makes sense. And then status is kind of repeated inside the error itself, which is not too descriptive. I'll take a look at this issue and I'll put my comments there. But you know, generally the structure looks fine, but we might want to think about the status and error fields.
Yeah, the error is definitely, I agree with you, Adam. The error is not adding any more context than you already have from looking at type and status.
Yeah.
So
Yeah,
unless it's a particular message, let's say in case of SQL is saying, I know, could not connect your database, you know, but I don't see a lot of value add in error.
Yeah, I mean, like from just by looking at it, we could replace status and error just with healthy, true, false, but let's take it offline.
Yep, correct. I think like in case of like I see what you're saying. So in case of gRPC, like it's saying that error connecting to Redis at localhost 6379, we can try to see that in HTTP we're also populating something like that in the error.
And one thing that I see in this API that is problematic is that we cannot use this as is into Kubernetes readiness point because it's returning okay.
It did not get this point because what I means like when I had checked with Kubernetes, so I was able to see like for the built-in secret store. So I was able to inquire that one, the health for that one. So
yeah, I think, Arthur, we need to discuss this offline because we have other means by which users can signal Kubernetes to, for example, restart the container. We have the init errors or error on init field on the component. And so if you don't switch that to false, it'll default true. And then Dapr will essentially crash and cause a restart of the Dapr container if component failed to load.
Yeah, for virtual load, yes, but after it's loaded, if it's a downtime, I don't think we have a way to restart after that.
Well, it depends. Some errors do lead to fatal errors, I think. And if not, then we might look at that as the way to restart the Dapr container. But definitely, you know, if we have this API in place, if it can be used to talk to the Kubernetes health check API endpoint, we should do that.
And if you look at the error codes and come up with a particular set of error codes, it'd be good to understand if there are sort of fixed set of error codes, you know, a bit like you have an HTTP that, or if we have to do anything inside the docs or on a per component basis to say these are the types of errors you could get back and what you can do with them. So we should just understand that if needed.
you mean to say, Mark, like having particular error codes just like in HTTP we had?
Yeah, well, no, you just might end up with these particular components now have these error codes, and people may or may not want to know, you know, a type of error that gets thrown and why. And I'm just pointing out if that's the case, you know, it might be worth documenting that in some way. Maybe they're self-documenting because their error code's descriptive enough and it says exactly what happens. But if not, then we should understand what it means. Because each component will have its different set of error codes, yes. Like a SQL component will have very different error codes from a you know,
Okay.
SQL component.
So you mean to say that propagating the error codes that we receive from like SQL server, so properly propagating it if it is doing that or not, correct?
Yes, the component can choose what to do there, yes, depending on what component understanding of health means to it, yes. Because each component will have its own interpretation of what healthy means to it. And it'll be because of the query failed or because it can't access the secret store or something like this. So you need to define what the error codes are and what they look like. So anyway, another thing to think about.
Okay, let's continue this. This is a good discussion. We'll continue this conversation offline.
Yep.
All right. Well, thank you, Dimitri, for running through that with us. I think it was good feedback.
Thank you.
And then lastly, we're going to have Arthur go through the pub sub subscription with stateful sets feature. So Arthur, feel free to take it away.
Okay, let me start sharing my screen. Okay, so I'm assuming this is people can
Yeah.
read.
Yeah.
Okay, so we probably have used PubSub in Dapr using deployments, right? And in this example, I'm going to show a MQTT deployment, okay, which is just a broker. So in this case, we're going to use Mosquito. Sorry, scratch that. We're going to use Kafka in this example. Sorry. So in this example, here's Kafka, and here's the Kafka component. The broker is configured in my cluster, and we have a consumer ID, which is standard for PubSub components in Dapr. And we're going to use this kind of templating scheme that we created in Dapr component for a while. There's a new option now for pod name. Previously, you used to have UID to have something random, but now you can have the pod name, which of course only works on Kubernetes, and you basically get the pod name of the instance injected and replaced here in the text. And in this example, we don't have authentication for Kafka. And then we're going to use the form from the quick starts, the React form to publish. And we have the subscriber. And the subscriber here, you're going to notice the difference. This time we're going to use a stateful set. We're going to start with one replica, but we're going to scale to more as part of the demo. And everything else looks pretty much the same as a deployment. I think also service name, I think it's required as part of a stateful set. And if everything else is the same as if we would do for a regular deployment. So this is everything you need. The MQTT thing is not really required, so you can ignore that. Let me just delete that file for now. And then these are the three things you need. Okay. So first thing you're going to do is I'm going to do an apply on the deploy folder. And we got the component, the service, the deployment for reactor form, and the stateful set for the Python subscriber. And then we're going to do get all here. Okay. Okay, it's running already. And you can see the Python subscriber has and React form both has the Dapr sidecar. So now what we're going to do is we're going to look at the logs. So just let me open up the logs here for another tab. Okay, so it's up and running. And what I'm going to do for this demo is I'm going to scale the Python subscriber to 3. So now it's scaling up. Okay, 1 and 2 are pending. Python subscriber 2. It's running. We're going to wait a little bit longer until deployment takes place. Okay, so 1 is running and 2 is running as well. So if you just do a quick look here, you're going to see now we have 3 subscriber for the Python app. So now I'm going to start to see the logs on each one of them independently. So we're going to do this one for 0. We're going to have this one for 1. We're going to look at this one for the third one. And here I'm going to do a port forward for the React form so we can start publishing some messages. Something weird in my copy and paste. Let me try again. Okay, port forward is working. So I'm gonna open the React app, just do a refresh. Okay, so we're gonna see demo message 1. I'm gonna send that, and then we're gonna send also 2, 3, and as you can imagine, we're gonna see those 3 messages on each one of the subscribers. Okay, same thing. Now what we can do is as well is we can now let me just show to you how it looks like on Kafka. I install I don't want to Bing search this. Okay, and if I look at consumers, you're going to see how we used the pod name as the subscriber in Kafka. Now, let me snooze this. So now what we're going to do is we're going to stop. Actually, we're going to delete. And it's terminating. And what we're going to do as this terminates, just wait for this to be terminated. Okay. 1, 2, and 0. Okay, they're terminated. So what we're going to do is I'm going to go and open up the browser, and we're going to publish again. We're going to publish demo message. Call that 10. And we're going to do 11, 12, 13. So as I come back and I do apply, the stateful set is created one more time. And I'm going to scale to 3 replicas as well. So the 0 is running, 1 is running, 2 is running. And now if I look at the logs, you're going to see that it started and got the messages that I published before, 10, 11, 12. And the same thing we have for the other replicas. So what's happening here is that each replica keeps track of its own consumer ID, and in a broker like in Kafka, you can actually get that memorized and you reuse when it comes up again. So so that is a way that if you want to have a message broadcast, you can use, or if there is like in MQTT, you can use like a shared consumer model where each instance gets one copy, the message is delivered to one consumer. not to all. So that's based on the broker configuration. But now you have control over the ID, consumer ID of each instance of the app. And that's all I had. So thanks very much.
Great stuff. I think this is really useful.
Great. So thanks, Archer, for showing that. We're just about out of time. We have a minute left. Unfortunately, I don't think we're going to have time for today to do an open discussion. We'll save that for the next community call. But I do want to thank all the presenters and thank everyone for joining today. And yeah, we'll, open to feedback. The proposals are all, on GitHub. And yeah, thanks for attending. We'll see you in the next one.
Okay, thank you.
Thank you.